Hello, and in part 3 today we're going to talk about our first type of chemical reaction. That is going to be a precipitation reaction. This is a very simple, straightforward reaction. It's very, very common that we see that we're going to do in lab, and you'll see this quite often in whatever field you may be part of. So let's look at what happens in a precipitation reaction. So if I use this as an example, some calcium chloride, and I'm going to mix that solution, because the label there is aqueous, so we know I've got a solution of calcium chloride and a solution of sodium carbonate, and those are in two separate beakers. So when I pour those two beakers together, when I combine my two reactants, they're going to react together to form some calcium carbonate and some sodium chloride. And I can see my label for calcium carbonate on the product side is a solid. That means that's going to form a precipitate, and that precipitate is going to be more dense than water, and it's going to fall to the bottom of the beaker. The sodium chloride is going to stay in solution, so we're not going to see that nothing is actually happening with those sodium or those chloride ions. So if I break this up, because I'm in solution, I know that my calcium chloride has completely dissolved, it's dissociated. Same thing with my sodium carbonate. So what actually exists in my beaker are calcium ions, chloride ions, sodium ions, and carbonate ions. That's what actually is floating around in the beaker, all hydrated and solvated, surrounded by water molecules. When they come together, what happens is the calcium and the carbonate come together to form a solid. So now those two ions are now held together, those are together, that's a solid molecule. And the sodium and the chloride ions are still solvated, floating around in solution. Okay? So that's what's actually happening in the precipitation reaction. On the reactant side, everything is dissolved and in solution. And on the product side, we see the calcium and the carbonate stuck together, precipitating out, and then the sodium and the chloride is still floating around in solution, completely solvated. So these precipitation reactions follow a pattern, and that's what we have here. There's our reactants AB is reactant molecule 1, reactant molecule 2 is CD, and we can see that they're going to form CB and AD. So another name for precipitation reactions is a double displacement. Basically, I'm just swapping my cations. That's all we do. I just swap partners. That's how we figure out, we take our reactants and figure out what our products are. We don't actually have to give you what the products are. If you understand what precipitation reactions are talking about, what they're describing, what that term describes, we just take our cations and swap partners. And that's all we need to do. And then once we based on that, we see that either CUB or AD is insoluble, that means it's going to precipitate out. And that's where we need to know our solubility rules. So this term precipitation reactions allow us to be able to identify and figure out what our products are. Once I know what those products are, I need to know my solubility rules to determine if one or both of those products is now insoluble and forms a precipitate. If they're still soluble, we can put an aqueous label behind the product. If it's soluble, or if it's a solid, then we can add that S label. And those phase labels are really, really important in these precipitation reactions, so we know what's in solution, what's precipitated out, where all of our ions and our compounds are going to be. So I mentioned at the end of the last section that I was going to put up this solubility rules. So this is what's available on Moodle. It just gives us some ions that are always soluble and the exceptions of when things are soluble or insoluble. Right? So this is a list that you don't necessarily need to memorize, but you're going to be working with us a lot, that you should have a really strong familiarity with some of these, especially the compounds that are always soluble. Sodium salts, potassium salts, ammonium salts are always soluble. Things that contain nitrate, acetate, chlorate, or perchlorate are always soluble. So those I would certainly try to remember. Those salts are always soluble. Those are always going to stay aqueous in solution. They're never going to precipitate out. The others are going to have some exceptions to when they're going to be soluble or not soluble, depending on what the cation or anion pairing is. And again, this is posted up on Moodle as a reference for you. So let's look at another example here. I have some lead nitrate and some potassium iodide. So those are my two solutions. They're both dissolved. So what I actually have in those beakers are lead and nitrate ions in one beaker, potassium iodide ions in the second beaker. So when I pour those together, the lead and the iodide come together and form that solid lead iodide, but the potassium and the nitrate still stay solvated and dissolved in solution. So the lead iodide precipitates out, the potassium and the nitrate still stay in solution. So here's a couple questions for you. So first one, which of the following are soluble in water? So looking at this grouping, use your solubility rules and identify which of these are going to be soluble in water. All right. So our correct answer is C. So all sodium salts are soluble in water. So in option 2, potassium salts are always soluble in water. Number 4, ammonium salts are always in water. And number 6, that's the acetate ion, and that's also sodium. So that's doubly soluble. So both the sodium and the acetate tell you that this is soluble in water. Right? The silver chloride and the lead chloride are not going to be soluble. Let's look at this one. So which ionic compound would combine with sodium chloride to form a precipitate? So hit pause and work your way through this. Okay, so before we get into this, we want to try to limit what we're looking at. So we know sodium salts are always soluble. That's from our solubility rules. If you memorize any solubility rule, that's the one to always know. Sodium salts are always soluble. So that means all of these anions in this list don't matter. They're going to pair with the sodium salt, which is always going to be soluble. So it's just looking at the chloride pairing with potassium, chloride with calcium, chloride with silver, chloride with magnesium. So potassium salts are always soluble. So when you get to calcium, silver, and magnesium, we need to look at some of our exceptions, and that exception is silver chloride is going to always be insoluble. It's always going to form a precipitate. So the silver nitrate, when I add silver nitrate to sodium chloride, I'm going to get a silver chloride precipitate falling out of solution. All right.